This is what I'm using to light the laminar flow. I've used an old PSU from a computer I had, 400 watt, and that gives me about 18 amps to 20 amps on the 12 volt rail. That's what supplies electronics. I'm using ProLight 5 watt LEDs, red, green and blue. I'm controlling them with an RGB controller. BigClive.com supply this. It's only about £8.50. It's a home build. Uses MOSFET transistors for a decent output, and a small microprocessor, PIC 12 series, that he programs with software. And there's about a dozen effects, lighting effects you can use. Okay, that controls the ProLight 5 watt LEDs mounted to heat sinks. These ballast resistors, the limit resistors, are 11 watt rated, the 4.7 ohms each. Blue, green, and there's red. Big hunk of hardware on top. It's just a clamp I've made up to clamp the fibre optic, 3mm fibre optic. That will actually be used to shine into the laminar flow. There's the fan from the PC that I'll use to cool the heat sinks, although they don't generate too much heat, bearable. And I'll turn them on in a second. You'll see they're controlled by pulse width modulation, and it's an interesting effect. You'll see on the camera as I turn it on, you can actually see the pulses. Here we go, turn the power supply on, and there's one of the displays. You can see there, you can see what I mean about the pulse width modulation. You can actually see the effect. It's quite cool, isn't it? Well, I'm mounting this in it's actually a toolbox, a plastic Stanley toolbox, so it'll be hopefully no light will escape from the box itself, just out of the fibre optics, which will go to the laminar. Okay, more videos when I get it fitted in the laminar flow. Let's see what it looks like when it's shining through the flowing laminar jet. Okay.